Let's discuss the question number 10 from test 1, which is from fluid mechanics. Question number 10. Okay, so what is given is a piece of metal of specific gravity 7 floats in a mercury of specific gravity 13.6. So you have mercury here, liquid mercury, and a piece of metal is there which is floating. Floating means some portion of it is inside and some you can see it's above the free surface of mercury. Okay, so specific gravity is given. Now specific gravity of the metal is basically your density of the metal by the density of water, and density of water is 1000. So this is a specific gravity of the metal. So from this I can write rho of a metal, which is density, and I can write 7000 kg per meter cube because water's density is 1000 kg per meter cube. Similarly for mercury also it is 13.6 into the density of water, going by the same logic, because going by the definition of specific gravity basically. So 13.6 into 1000 will give you 13600 kg per meter cube. Okay, now let's come to the problem. What is given is a piece of metal is floating in the mercury. Now let's draw the free body diagram of this metal. You have the weight of the metal, which is mass into g, and then because some portion is inside a fluid, the fluid will the fluid will exert a force called buoyancy force on the metal, which is denoted by Fv. Now for this to be in equilibrium, mg has to be Fv, static equilibrium basically. So mass of this metal, so let's compute each of the terms. Now mass of the metal is basically the density of the metal into the volume of the metal. Okay, and volume of the metal, let's say it is, so density I'm writing 7000, volume of the metal, let's say it's V. Now buoyancy force Fp, because I need to use this relation, so let's calculate what is there on the left hand side, what is there on the right hand side. Now buoyancy force is nothing but weight of the liquid displaced. Okay, so the buoyancy force will be the weight of the liquid displaced, means let's say the volume V that is inside be Vd. So it will be the weight of the liquid that is displaced in this volume, or basically the weight of the liquid in this volume. Suppose if the metal is not there, then how much mercury you can fill in this volume Vd. So that will be the mass of the mercury. Okay, that comes, the mass of the mercury into g, basically the weight of the mercury that comes in this Vd. So weight of the mercury that comes in Vd will be basically Vd into rho of mercury. Okay, so this is basically how much mercury will weigh. So let me just write down mercury will weigh in that Vd. So it is rho mercury Vd. So now let me use this relation. So it will be 7000 V into this rho mercury into Vd into G, and remember there is a G here. I have just substituted, I am basically using this relation, so there will be G here. 7000 V is mass, G is G, and this Fb is nothing but this. Okay, rho of mercury we have calculated, which is 13600 Vd into G to 7000 V into G. Now G is common on both sides, so what is asked is the fraction of its volume is under mercury. So whatever the volume that is under mercury, that divided by the total volume will give me the fraction. So Vd by V is what is asked, and that comes out to be 7000 by 13600, and if you use a calculator it is 0.514, and the closest answer is